First, it's nominal scale, and second one is ordinal scale, third one is interval scale, and fourth one is the ratio scale. So these are the various scales in which the variables are expressed or measured. First, nominal scale. In nominal scale, it actually refers to categorizing population into different subgroups. So whenever we assign a variable with a nominal scale, it automatically categorizes the whole population into various groups. For example, gender. If we assign a value or data to the gender, it's either male or female, right? So this actually categorizes the population to whole different set. So nominal scale, it is also a categorical scale. In case of literacy status as well, it's literate and illiterate. So they can be categorized into various other types as well. So those scales which categorize population into different groups, these are the nominal scale. For example, age groups as well, from 10 to 20, 20 to 30. So these all are the nominal scale. Second one is the ordinal scale. While talking about the ordinal scale, nominal scale, ordinal scale, interval and ratio scale, we need to know about the order and differences. In case of the ordinal scale, whenever any type of data are expressed in the ordinal scale, then it represents order, but it fails to signify the differences between the measured values. For example, various abstract terms, they are actually expressed in ordinal scale. Movie rating, pain scoring, happiness, degree of satisfaction, right? So let's consider about pain scoring. So if it is scored from 0 to 10, and let's consider there are three different patients, A, B and C. Alright, so obviously the pain these three different patients experiences are in an order. For example, the pain experienced by the patient C is obviously greater than the pain experienced by patient A and B, and similarly the case for B. The pain experienced by the patient B is greater than the pain experienced by the patient A, whereas it is smaller than the pain experienced by the patient C. So it represents an order. But the difference of the pain experienced by B with respect to A and the pain experienced by patient C with respect to the patient B, they are not they can be equally same, though if we subtract the pain scores of these individual patients, we get differences as a 2, but as these are the abstract terms, so they can't be actually expressed in quantitative manner, or the differences are not same. So it only expresses an order, but it fails to express the differences between the measured scale. Another one is the interval scale. In case of interval scale, again, in this type of scale, it shows both type of characteristics. So it represents both order, and the differences are same in this case as well. There are examples. First, most of the measurement scales, like as degree Celsius and several others, they fall under either interval scale or the ratio scale. If they fall under the interval scale, the only difference is there is no zero, right? In case of the interval scale, the differences are the same. For example, the difference between 60 degrees Celsius and 40 degrees Celsius is equal to 20 degrees Celsius, and the difference between 80 degrees Celsius and 60 degrees Celsius, it is also equal to the 20 degrees Celsius. So the difference is the same. So it represents both order and the differences. The place having the temperature 80 degrees Celsius, it is obviously hotter than place B, where the temperature is 60 degrees Celsius, right? So it represents both order and differences, but the main thing is it does not have true zero. For example, temperature in degrees Celsius. Whenever temperature It's expressed in the form of degree Celsius. 0 degree Celsius, it is not equal to the absolute zero. There is still some amount of temperature present in any object. For example, ice. It's not an absolute zero. It's when it is expressed in the form of Kelvin, it is 273 Kelvin. So the zero here does not signify true zero. So that's the main feature of the interval scale. But in case of the ratio scale, it always everything, right? So it shows both the characteristics of orders and the differences in the major scale. And here they have true zero. Zero, it literally means zero. For example, temperature in degree Kelvin, where 0 Kelvin, it is equal to the absolute zero. Similarly, in case of height and weight, which are the commonly measured variables, these are also zero. For example, if we consider height as a 0 centimeter, then there is nothing, right? Absolutely, it's zero. And weight 0, if weight is equal to 0, and then the body does not have any weight, right? So here 0 signifies absolute zero. So these are the various types of measurement scale.